Hey guys, so today we are going to discuss what is controllability and observability in MCT, that is modern control theory, or we can also say the control system. So now first of all we are going to see that what is controllability. So a system is said to be controllable if it is possible to change or manipulate its state from initial state to a desired state. That is, if we are able to manipulate a system from its initial state to a desired state in a finite time interval, then it is said to be controllable. That is, if we can change a particular state of a system, suppose this is a state of a system, from its initial state to another state, that is a desired state. That is this is the x1 initial state, and this is the x2, which is the desired state. So taking our system from x1 to x2 in a finite interval of time, say t1 to say t0 to t1, then the controllable system is formed. That is, the system that we have will be controllable. So now let us see what is observability. Now a system is said to be observable if it is possible to determine the initial state of any system by varying or by observing the output in a finite interval of time. What we mean to say by this is that a system is said to be controllable if it is possible to determine the initial state of any system variable. Suppose we have a system variable, say x, and if it is possible to determine its state by observing the output in a finite time interval, then the system is said to be observable. That is, these definitions are important and you should learn them and write them in your notebook, as these can be asked in your exams. So now let us understand what is observability and controllability in a little more detail. So let us first see that what is controllability. So now let us see, first we will write the state equations. That is, the state equations are given by x dot is equal to ax plus bu and y is equal to cx plus du. These are our state equations or the state space analysis. So now if we have to find out the controllability of a system, that is, if we have to find out the controllability of the state space analysis, then what we will do is that first of all we will find a matrix, and the value of that matrix will be given by this, that is, it is equal to b a square b until a to the power n minus 1 into b. So this is the matrix that you will have to find in order to know whether your system is controllable or not. So now after finding out this matrix, the second step that we have to do is that we will have to see whether the determinant of this matrix, that is, this is the QC matrix, we will be calling it as QC. So now the second step is that we will see the determinant of the QC matrix. If the determinant of the QC matrix comes out to be 0, then it is uncontrollable. Otherwise, if the QC matrix is not 0, then our system is said to be controllable. So this is the simple trick that we can use, or the steps that we can use in order to find out the controllability of any system that is given to us. But the only condition is that we should know that what is the A matrix, and we should also know that what is the B matrix. And then using this matrix, that is B, AB, A square B till A to the power n minus 1B, we can find out whether the system is controllable or not by simply finding out the determinant of the matrix. So now let us see the second part, that is the observability part. Now a system is said to be observable. Suppose we again have the state analysis equations, that is, the x dot is equal to ax plus bu, and we have y as cx plus du. So now we will use another matrix in order to find out the observability of a system. That is, here we will be using a matrix called as QO, which will be given by CT, AT AT square CT until AT to the power n minus 1 CT. So T here is the transpose, as you must be familiar with this term, that the T over in this matrix represents the transpose of the C and the A matrix. So this is the matrix that we will have to find. Now similarly, as we are done for controllability, here we will again find the determinant of the matrix Q. And if it is not equal to 0, then it is observable. Otherwise, if this determinant, the determinant of this matrix Q0 or Q0 is 0, then it is not observable. So these are the simple conditions that we have to find out in order to know whether the system is controllable or observable. That is, now let me just revise the concepts again. Let me change the color. So now first we saw controllability. We first of all discuss its definition. That is, this is the definition, and this definition is important. Please learn it as it can be asked in your exam. And secondly, we discuss the definition of observability. These are very simple definitions. There is no need to further explain them. Now we saw that how we have to find out the controllability in a numerical. That is how to find the controllability of a system. That is, suppose we are given the state equations, that is x dot is equal to ax plus bu, y is equal to cx plus du. From there we will take the matrix B and A. Then we will find out this particular matrix, and then we will find out the determinant of this matrix QC. From where we will see that the system is controllable if it is not equal to 0, that is the determinant is not equal to 0, and it is said to be uncontrollable if the determinant comes out to be 0. Now lastly we discuss the observability, that is how to find the observability of a system. That is, again, we were given a system of equations, that is the state space equations. From there we took the matrices A and C, took their transpose, and using that we found out this matrix. That is, this is n minus 1. And this is Q0 matrix, which we use to find out the observability. That is, if this comes out to be 0, then it is not observable, and if this comes out to be equal 0, then it is observable. So these are the simple conditions that we have to find out. Do not worry, we will now discuss a question on how to solve these numericals based on controllability and observability, and you will be easily able to understand that how we have to find out the matrices Q0 and the matrix QC. So now let us come to a question. Let us try to do a question first. Let us say question number 1. Now suppose that we are given a matrix, that is x dot, or we are given the state space model, that is 0, 1, minus 1, minus 2, x1, x2, plus 1, minus 1, u. And we are given the y matrix as 1, 1, x. So now you must be familiar that what these matrices represent. As you must have studied MCT or modern control theory, that this represents the A matrix, this represents the B matrix, and this represents the C matrix. In this particular question, the D matrix is 0, which comes out to be over here. So there is no need to consider the D matrix, and anyway we do not need D matrix in order to find out the controllability or the observability of a system. So now let us perform the question. That is the answer for this one, question 1. First of all, we will find out the controllability. So for controllability, as we discussed before, we will first find out the matrix QC, which is given by B, AB, A square B, until A to the power n minus 1 into B. So now, how many terms do we have to consider in order to find out the answer for this particular question? So in order to know that, first of all, you will have to see that what is the size of the matrix A, which will help us determine the number of terms that we have to use. That is, we can see the A matrix is a 2 cross 2 matrix. So the number of terms that we will be using in this matrix will be 2, that is B and AB. So I will again rewrite this matrix as B, AB. That is, in this particular question, we only have to find these two matrices. That is this matrix, which will consider of 2 terms, that is B and AB. So now, first of all, let us write what is the B matrix. As we saw above, this is the B matrix which is given in the question, which is given by 1, minus 1. And similarly for the second term, AB, we will write AB, that is, we will multiply these two matrices, which will come out to be equal to 0, 1, minus 1, minus 2, that is the A matrix multiplied by the B matrix, which is 1, minus 1. And on multiplying them, you will get minus 1, 1 as your final matrix AB. Now what we will do is, we will simply put this part 1 and part 2 in this matrix. That is, now we will write the QC matrix as 1, minus 1, minus 1, 1, That is, this part represents the AB matrix multiplication and this part simply represents the B matrix. Now we will come to the second step that we have to do in order to find out the controllability. As we discussed above, in order to find out the controllability, we will first now find the determinant of this matrix QC. That is, on now we will find out the determinant. On doing so, you will get 1 minus of minus 1 into minus 1. On doing so, you will get 0. That is, you will get 1 minus 1, which will come out to be 0. So as we had explained earlier, if the matrix determinant of the matrix QC comes out to be 0, then it is uncontrollable. So this particular matrix or this particular system over here is uncontrollable. So now what we will do is we will find out the observability. Now how do we find out the observability? Let us see. That is, for observability in this same question, that is, we are doing the same question only now, but now we are going to find out the observability. That is, in this in this particular question, we will write the Q naught matrix as CT AT into CT. As we had discussed earlier, we will only be taking two terms because we have the A matrix as a 2 cross 2 matrix, as we had done for controllability. That is, we took only two terms. So here also we will be taking only two terms. So now from the above question, this is the C matrix. That is 1 comma 1. That is, C matrix is R1 matrix, 1 1 matrix, and A matrix is the same as the before one as we used earlier. That is 0 1 minus 1 minus 2. But the difference over here is that instead of writing the C matrix, we will be writing the transpose. That is, first of all, we will write the C matrix, which is 1 1, and we will write the A matrix, which is given by 0 1 minus 1 minus 2. This is the matrices given in the question. So now in order to find the observability, what we will do is we will find out the transpose of CT. That is, we will write CT, and transpose of CT will be simply the inversion of this. That is, we will write 1 and 1 in the column wise form. Now similarly, we will find out the transpose of the A matrix. That is, on finding out the transpose, you will write 0 1 minus 1 minus 2. I hope you know how to find out the transpose. If you do not know, just write in the comment section transpose, and I would surely make another video in order to explain what a transpose is. But now continuing, as you know that what a transpose is, we will now find out AT into CT. That is, we will write 0 minus 1 1 minus 2. That is the transpose of A multiplied by the transpose of C. That is 1 1. And not doing so, what you will get is that you will get minus 1 as your new matrix, which is ATCT. So now we will simply take these values. That is, we will simply take these values of ATCT and CT and put them in the Q naught matrix. That is, on doing so, you will get Q naught as, first we will write CT, that is 1 1. Then we will write minus 1 minus 1. Now let us come to the last step, or the second step, in order to find out the observability. That is, on doing so, we will find out the determinant. That is, on finding out the determinant, you will get 1 into minus 1 minus of 1 into minus 1. Now you will observe that you will get the answer to come out to be 0. So over here also our system is not observable. So let us see what happened in this question. First of all, this question was given to us. So first step is to determine that which matrix is which. That is, this is the A matrix, this is the B matrix, and this is the C matrix. Now we will write these matrices separately. Then after writing them separately, we will find out the controllability as asked in the question. In order to find that, we will find out the QC matrix, and whose number of terms will be determined by the size of the matrix A. As we know that the size of the matrix A is 2 cross 2. So we took two terms in the QC matrix. And then we found out the terms for the QC matrix. That is, we found out B, then we found out AB. Then we simply put these two equations in this. That is QC. Then we found out the determinant of QC, which came out to be 0. So it is uncontrollable. Now secondly, we found out the observability. And similarly, we took two terms for the observability matrix, and then we wrote the C and the A matrix as given in the question. Then we wrote the transpose of C, and then we wrote the transpose of A. Then we multiplied the two of them and put them in the Q naught matrix. On doing so, we will get this matrix, and then we will do the last step, that is find out the determinant, and on doing so you will get the determinant as 0, which clearly states that it is not observable. So guys, let us do another question in order to make our concepts more clear. That is question number 2. Now suppose in this question we are given x naught is equal to minus 1 minus 1 0 1 0 into x1 x2 plus 1 0 into u. And over here we are not given the y matrix, we are only given the x matrix, that is the x equation. We are not given the y part. So we do not need that, because in this question we are only going to ask you the controllability. And by now you must know that what the matrix for controllability is. That for the matrix for controllability that we have to use is given by b, ab, a square b till a to the power n minus 1 b. So you must have observed that we only need two matrices, that is b and ab. So it doesn't matter whether y is given to us or not, we only need the a matrix and the b matrix. So now let us proceed with the question. So over here also the size of the a matrix is a 2 cross 2 matrix. So what we will do is we will only take these two terms, that is the first two terms of the QC matrix. That is we will again rewrite QC, which will come out to be b is equal to ab, and now we will simply put the value of b over here and ab over here. So first of all, let us write the value of b, which is given in the question, which is 1 0, and now we will find out ab. That is, we will multiply matrix A, that is minus 1 1 0, and we will multiply the matrix B, that is 1 0. On doing so, you will get the final matrix as minus 1 1. So now we will take 1 and we will take 2 and put them in this matrix. On doing so, you will get QC as 1 0 minus 1 1. Now lastly, what we are going to do is we will find out the determinant of this matrix, which will come out to be 0 1. That is, now we will observe that the determinant of QC is not equal to 0. So what we can say about this system is that it is a controllable system. As we had discussed earlier, that if the determinant comes out not to equal to 0, then we will write that the system is controllable. So this is a very simple concept of controllability and observability, and you will get the hang of it if you just try these two questions. Now let us understand one more concept, that is, this is the last concept. In all the above questions, what we did is that we had a 2 cross 2 matrix, and what we did is that we took the QC matrix as controllability matrix as B, AB, and we took the observability matrix as CT, AT, CT, because it was a 2 cross 2 matrix. That is, the A matrix was a 2 cross 2 matrix, which was given in the question. Now suppose if we are given a matrix that is, say, 1 2 4 1 0 4 0 1 9. Suppose this is a matrix that we are given. So you will see that this is a 3 cross 3 matrix, as the size of the matrix A is 3 cross 3. So now what we will do is that we will take three terms in the QC matrix, that is B, AB, and A square B. So these are the three terms that we will be taking in order to find out the QC matrix. Now exactly same, it is exactly the same. Now we just have to find out this one more term. That is, we will find out A square into B. That is, first of all, we will square the A matrix, then we will multiply it by B, and then we will put that resultant matrix in this matrix, and we will get the final QC matrix. Now similarly for observability, what we will do is that we will take CT, AT, CT, and we will write AT square into CT. So over here also we have taken up three terms. That is, these are the three terms, that is CT, AT, CT, and AT square CT. So this is exactly the same, only that this term has been added. And similarly, what we will do is that we will find out the transpose, as we did for these two, of A, then we will square it, and then we will multiply it by CT, and then we will take that resultant matrix and put it back over here. So this is the simple concept that you will use. Even if it is a 4 cross 4 matrix, what you simply have to do is we will again add a term a cube b over here at the end of after a square b for controllability. And for observability, what we will do is that we will simply add another term after 80 square ct, which will be given by 80 cube ct if it is a 4 cross 4 matrix. But 4 cross 4 matrix will never be asked in the exam. Maximum they will ask you a 3 cross 3 matrix or a 2 cross 2 matrix. So it is a very easy concept, whether it is a 3 cross 3 matrix or a 2 cross 2 matrix. The concept remains the same. So guys, this is it for this video. If you are able to understand it, just write wow in the comment section, and it would be great to know that you are able to understand it. And if you want me to do more questions on controllability and observability, just write more questions, or you can write more Q's with an exclamation mark in the comment section, and I would know that should do another video on questions of controllability and observability. So guys, this is it for this video. See you in the next one.